Like any teacher will tell you, units are important. Like saying something is 100 degrees doesn't mean anything. Are you talking degrees Fahrenheit or degrees Celsius or just degrees of rotation? Pretty big difference between those things. Units are a major way we describe the world around us, but in conversation, they can go by so quickly that we don't give them a second thought. And maybe we should. After all, many units are named after influential scientists. So by looking at their stories and the discoveries they made, we can get a sense of how we've learned so much about our universe. On a different note, we can also get an idea of the kinds of voices that researchers historically valued, which means that demographically, this list might not be a shocker. It's a bunch of rich white European men. Rich white European men who made some important discoveries. Every day, millions of people use a temperature scale named after Daniel Gabriel Fahrenheit, who was born in 1686 in what is now Poland. So probably I pronounced his name wrong. He invented his scale back in 1724, and it dominated scientific measurements right up until the middle of the 1900s. So even though using it is something Americans get picked on for, it's really no surprise that it remains widespread. But really, Fahrenheit wasn't Fahrenheit's biggest contribution to science. Instead, he stood out because of his thermometers. Thermometers in the 18th century were glass tubes filled with a liquid that expanded as it warmed up. Typically, they contained water, oil, or purified alcohol, but those liquids weren't great at that job because they tended to freeze or boil at pretty mundane temperatures. And once that happened, the thermometer was useless. Fahrenheit improved this system in two big ways. For one, he made his thermometers using mercury. Mercury stays liquid across a much wider range of temperatures, so you could use mercury thermometers in more situations. The purity of mercury also varied less from place to place, meaning Fahrenheit's thermometers would behave consistently regardless of where they were made and sold. Admittedly, a few people had tried mercury thermometers before, but mercury doesn't change size quite as much as other liquids, which meant that it was harder to tell when the height changed in the tube. So Fahrenheit's second improvement was to make his instruments with really thin glass tubes. Whenever the mercury inside expanded even the tiniest bit, he could tell, and he could measure it. Fahrenheit was able to make those narrow tubes over and over and over again, and he could get mercury no matter where he sold them. So his tools quickly spread all over Europe, as did the scale he invented to go with them. Eventually, more precise and accurate thermometers were invented, but the idea to use mercury stuck around, along with what was by then commonly called Fahrenheit's scale, or as we know it today, Fahrenheit. The watt is a unit of power, defined as the consumption of 1 joule of energy in 1 second. For reference, 1 watt is about how much energy 2 bulbs consume on an older string of Christmas lights, which is not very much at all. So it's a little bit of energy, but James Watt, its namesake, was no chump. He was a Scottish engineer and inventor in the late 1700s and early 1800s, and his biggest claim to fame was his steam engine. Kind of like what happened with Fahrenheit and mercury, Watt did not invent the modern steam engine. That happened in the 1690s, but he did make some significant improvements to them. In 1764, he realized that the steam engines of the time wasted a lot of energy. Steam engines work by boiling liquid water into steam, which expands and pushes on something like a piston. Pushing a piston once isn't generally that helpful, so the steam then gets collected, cooled down, and condensed back into a liquid so that it can reboil, push again, and repeat the cycle. Original steam engines used the same chamber for both the heating and the cooling stages. But Watt realized that constantly changing the chamber's temperature wasted energy that could have gone into moving the piston. After all, every time you cooled the chamber down, you undid the work you would put in to heat it up in the first place. To fix this problem, Watt designed an engine with separate boiling and condensing chambers that was far more efficient than other engines of the day. His engine would let you accomplish way more with the same amount of energy. Like if you could only burn a certain amount of coal each day, you would get more out of it with Watt's design. The engineer also made lots of tweaks and improvements to his work and had plenty of other inventions too, including a photocopier, but a better steam engine was his biggest legacy. And because he did so much to improve how people use energy, the unit of energy consumption was named after him in 1882. At first, the Ampere might sound less familiar than other units we've talked about so far, but its nickname might ring more of a bell: the amp. Amps measure electric current, the amount of electric charge moving past a point in a given length of time. Cell phones draw 1 or 2 amps while they charge, and each ampere is equal to about 6 million trillion electrons going by per second, which is a lot of charge. The ampere is named after André-Marie Ampere, who was a physicist that worked in France around 1800. Scientists in Ampere's day were just starting to seriously study electricity, and they'd already discovered that a current in a wire could affect a compass. This sounds weird, but it proved that there was some sort of connection between electricity and magnetism, and Ampere wanted to understand that connection better. He sent currents through 2 parallel wires, and found that the wires either attracted or repelled each other depending on the direction of flow in each wire. The wires acted like magnets with north and south poles, except that Ampere didn't have any magnets in his experiments. He only had these 2 wires carrying currents. Eventually, he realized that current was like a magnet that you could turn on and off. And today, this idea is used in electromagnets that spin motors in everything from ceiling fans to car engines. But this isn't where Ampere's work stopped. After this, he also discovered a precise relationship between the amount of current and the strength of the magnetism it produced, a relationship that is today known as Ampere's law. His research into electromagnetism laid the groundwork for some of the most important physics in the last 2 centuries, work that has affected everything from power generation to computers. So even though Ampere did a lot of research during his lifetime, he's most famous for his electromagnetism work, and since 1881, his name has been connected with the unit of electric current. Hertz is a measure of frequency, how often something happens. 1 hertz is a full cycle each second, and although you can use this unit to describe a lot, it's often used in regards to sound. Humans, for example, can generally hear sounds between about 20 and 20,000 hertz, or between 20 and 20,000 full vibrations of the air every second. This unit is named after German physicist Heinrich Rudolf Hertz, who in the late 1880s became the first person to transmit and detect radio waves. This happened when he was trying to confirm an idea from about 20 years earlier, that a moving electric charge sends out waves of electricity and magnetism that can move other charges around. To do this, Hertz designed a series of experiments in which he looked for sparks, the most obvious signs of moving electric charges. First, he connected 2 circuits together and noticed that when one sparked, the other often would too. Then he physically separated the circuits, connecting only one to a source of electricity, and he found that sparks in that one could still make sparks in the other. Electricity wasn't flowing between them, but energy was. This was the proof he was looking for, that moving charges in the first circuit were emitting waves that pushed charges around in the second. To confirm this, Hertz even bounced the waves from one spark off a mirror before they reached the second circuit, and that still caused sparks. By carefully going step by step, Hertz ruled out other possible causes of the sparks and confirmed that the waves had the properties everyone predicted, properties like their frequency. Specifically, these waves wiggled about 100 million times each second, which, for the record, is the same frequency as the waves that carry the 100.0 radio station on modern FM radios. Of course, Hertz did not invent the radio. Going from sparks to songs took a bit more work. But he was the first to measure these waves and to prove that they were the same thing as regular light, just with a different frequency. And even though he made lots of other important discoveries, this alone was enough for the unit of frequency to be named in his honor in 1930. Finally, we couldn't do a list show about units without talking about Celsius. The Celsius temperature scale is named in honor of Anders Celsius, and he's actually an odd one out on this list because the scale with his name on it isn't very closely related to what he spent most of his life doing. He was, first and foremost, an astronomer, interested in auroras and the Earth's magnetic field. But today we remember Celsius because of a temperature scale he developed in 1742, in which water froze at 100 degrees and boiled at 0. And you might think that I said that wrong, but we didn't. It's not the modern Celsius scale, it's backwards, and arguably a little more useful. Other scientists besides Celsius had written written scales like this before, and they did it so that scientists got to write fewer negative numbers. After all, no matter how oppressive summers can feel, Earth's days never get hot enough to boil water, while in Sweden, where Celsius worked, lots of days are near the point at which water freezes. Putting the freezing point at 100 degrees and going up from there as it got colder meant scientists recording common everyday temperatures wouldn't have half their numbers with minus signs and half without. That meant fewer chances for a mistake when transferring data around. Within a couple of years, though, several people created versions of Celsius's scale with the modern numbering, because turns out they were fine with negatives after all. Regardless, much like with Daniel Fahrenheit, Celsius's scale became widespread because of how careful he was about calibrating it. Air pressure, salinity, and lots of other factors can affect the temperature at which water changes states. So Celsius was very specific about the conditions of the water as he was calibrating his scale. That made his scale more reliable and easier to replicate than those from other competing thermometers. Some people started calling the degrees on this 0 to 100 scale Celsius after its sort of creator. But others called it centigrade, which is Latin for 100 steps. The two names existed side by side until the scientific community officially named it after Celsius in 1948, although you will still hear some people say centigrade every now and then. Now, these five are hardly the only units named after people, they're just some of the ones you'll hear most often. But there are joules and newtons and pascals and curies and becquerels and farads and Kelvin, each with a scientist, a story, and a discovery or two hiding behind its inconspicuous name. Of course, there are also a lot of weird units of measurement out there, and if you want to know more about whether particle physicists can hit the broadside of a barn, check out our video about barns and other obscure units that scientists are still using today.